Demis Hassabis, the CEO of Google DeepMind, just published an essay on X that is quietly one of the most important things written about AI this year, and it went viral almost instantly. It lays out an actual framework for how AGI should be rolled out to the world, not just a prediction about when it arrives. And once you understand what he is actually proposing, you start to see why so many people in the AI world stopped scrolling and read the whole thing twice. This is not some random commentator either. This is the person actually building the technology telling you exactly how he thinks it should be controlled. He opens with the timeline question everyone wants answered. Hassabis says AGI, meaning a system with the full range of human cognitive ability, is probably only a few short years away, and that when we look back on this period, we will realize we were standing in the foothills of the singularity. Coming from the head of one of the 2 or 3 labs actually building this technology, that is not a throwaway line. If we take a few short years at face value, we are talking about something like 3 to 5 years, which is a genuinely short runway for a change this large. He is careful to say this is not like the internet or mobile phones. His comparison is the discovery of electricity or fire, and he puts it almost too simply, saying we have essentially found a way to make sand think. He argues the impact could land at roughly 10 times the scale of the Industrial Revolution, arriving at 10 times the speed, touching drug discovery, clean energy, and new materials, potentially reaching a point where resources stop being the limiting factor on human progress at all. But the timeline and the scale are really just the setup. The actual substance of the essay is a proposed framework for how frontier AI should be tested and released, and it comes in stages. Stage 1 is defining what actually counts as a frontier model in the first place. Hassabis wants a standards body, modeled on FINRA, the organization that oversees Wall Street, to set a capability threshold, separating ordinary AI systems from the small number of exceptionally powerful ones that need real oversight. A customer service chatbot or a small university research model stays completely outside this process. The classification is based purely on what a model can actually do, not on who built it. A giant tech company does not automatically qualify, and a small independent lab is not automatically exempt. Once a model crosses that capability line, it becomes a frontier model, and whoever built it becomes a frontier lab. Stage 2 is testing those models before they ever reach the public. Under the proposal, labs would voluntarily submit frontier models to the standards body up to 30 days before release, and independent experts would examine whether the model can do things like discover and exploit serious cybersecurity vulnerabilities, provide meaningful help with biological threats, circumvent its own safety restrictions, deceive evaluators, hide problematic behavior during testing, or act with dangerous levels of independence. The point is not only whether a model can technically do something dangerous, but how easily that capability can actually be reached, and whether a lab's safeguards would reliably stop it from being misused. Stage 3 is making sure those tests do not go stale. Benchmarks get saturated fast, sometimes within months, and a test that is difficult for today's models can become trivial for the next generation almost overnight. So the standards body would need to refresh its evaluations regularly, potentially every few months. Retiring saturated tests and introducing harder ones, while also keeping private, held-out tests that labs never get to see in advance. That last part matters more than it sounds, because benchmark gaming, where a model effectively learns the exam instead of the underlying skill, is already a real problem, and it can distort results in both directions, making a model look safer or more dangerous than it actually is. Stage 4 is what actually happens with the results. At first, submitting a model for review would be voluntary, giving the body time to prove its tests are accurate and consistent. But once that track record exists, Hassabis argues passing the assessment should become a legal requirement before a frontier model can be deployed in the United States at all, similar in spirit to safety, codes for food production or building construction. A model with no serious issues moves forward. One with manageable weaknesses gets released only once specific vulnerabilities are fixed, or certain capabilities are restricted. A model with more serious problems gets delayed until the risk is actually reduced. And the most extreme case, a model producing risks a lab cannot control, could trigger a coordinated slowdown across multiple leading labs at once, specifically because no single company wants to be the one that pauses while its competitors keep racing ahead. There is a fifth piece that gets less attention but might matter just as much, which is security. Hassabis argues frontier labs need protection, closer to what protects nuclear launch codes than what currently exists in AI development. A one-time pre-release test only captures a model at a single moment, so labs would also need continuous security practices covering the entire development process, protecting model weights and research from theft, limiting access to critical systems, and properly vetting anyone with access to the most powerful models being built. Right now, that level of security largely does not exist across the industry, and given how much of a target frontier AI systems are becoming for hackers and hostile states, that gap will not stay acceptable for long. Hassabis is upfront that none of this applies to smaller models or university research, since the exemption is based purely on capability, not company size, and the framework applies the same way regardless of what country built the model or whether it is open or closed source. Whether every country actually goes along with a shared slowdown if one becomes necessary is a completely different question, and one he does not pretend to have an answer for. It is worth being honest about that gap too. A coordinated pause only works if every major lab and every major government actually agrees to pause together. And right now, there is no real reason to expect China, or frankly any state under competitive pressure, to slow down just because a US-based standards body says the risk level has been reached. This framework is genuinely well thought out, but it is still built for a world where everyone plays by the same rules, and that has never really been true of AI development so far. Beyond the regulation itself, Hassabis raises questions that go well past AI policy. If AGI genuinely makes intelligence and the work it produces cheap and abundant, the entire economic system built on scarcity starts to strain, since wages and prices exist specifically to ration things that are limited. That opens the door to ideas like universal basic income, universal basic services covering housing and healthcare directly, or models where citizens hold something like a national dividend in AI-driven productivity. Though he is clear that nobody actually knows which of these would hold up at real scale, and that some things like land, energy, and human attention will likely stay scarce no matter what. He also raises the harder question of meaning. For most people, work is tied closely to identity and self-worth, and if a machine can do most of that work better, the question of what a person is actually for stops being philosophical and becomes personal. One path there is a real crisis of purpose, widespread aimlessness, and a loss of the structure that work used to provide. The other is closer to liberation, freeing people to spend their time on relationships, creativity, sport, and community instead of survival and toil. He does not predict which one wins, only that the answer will not be automatic, and that a Victorian factory worker and a modern office worker already found meaning in wildly different ways, so the shape of that answer has always been able to change. And the final piece is maybe the strangest. If AI accelerates medicine and biology enough to meaningfully extend lifespan, or if brain-computer interfaces start blurring the line between a person and their tools, some of what has always defined being human, limited lifespans, limited memory, being the smartest thing on the planet, stop being fixed facts. Hassabis is not answering these questions so much as insisting we start asking them now, while there is still time to shape the answer, rather than simply react to it. He closes the essay by saying what we collectively do in this window will determine how the next phase of civilization unfolds, and that safely stewarding AGI into the world could open a genuine golden age of discovery and human flourishing. Whether that framework actually survives contact with global competition and geopolitics is the real test, and it is one nobody has passed yet.